Hi everyone, welcome back to the Node.js Global Summit. Today we are having the junior track, and keep in mind that this is an online conference. This is quite new. There could be some connection issues and so on, but we're working hard to get them fixed as soon as possible. And as you can see, we already fixed the most of them. So please enjoy the conference. Now, our next speaker is going to be Nari Harutinen. And Nari is a practice programmer for more than 4 years. And Nari, we are connecting you now to the stream. Could you please tell us a few words about yourself? Hi.
Hello. I'm Nari from Armenia. I'm working as a backend engineer at Screenful. I've already 4 years of experience, and basically I use Node.js. I support Node.js community in my local country. I give talks in meetups and conferences, so I like to share my experience and knowledge with others. And I'm very happy to be here with a part of this Geekle Summit.
That's great. We are also excited to see you here. Tell us, please, is that your first online conference, right?
Yeah, it's my first online conference.
That's great. So that's the third speaker that has just the first experience now. So we are all more than excited. Nari, I wish you good luck. Could you please tell us just a few words, a quick introduction to your topic, and then you can also share your screen if you have any slides. I will add that shared screen to the stream. Meanwhile, just a quick presentation about yourself.
Sure. So today I will talk about event loop and Libyobi. Basically, we will dive deep to Libyobi, and we will talk about microtask and microtask. Also about threads, how is Node.js single-threaded or not, and how the stuff works under the hood. So that's all.
That's great. Thank you. All right, we are now going to your presentation. I'll moderate slightly the conversation. So I will join back to the session. I'll say 5 minutes left, then 2 minutes left, 1, and then we'll finish. So good luck.
Thank you. So let's start. Maybe I will skip the introduction part. Okay. The event loop was written by a reactor pattern, and even if you do some research and open the Wikipedia, you will see the basic structure of event loop, and you can understand how the whole concept works with this pattern. But right now I want to give a small demo and understand how this pattern works. Let's imagine we have IO request. It's file system read file, and whenever you call your function, the IO request receives event loop. After then, event loop forwards this request to the multiplexer, and at this time, event demultiplexer does hardware IO work. Basically, it's the same function, but in C or in C++ level. So if you want to read a file, then one script from C level will be executed, in our case, in Node.js. And in case when we will have the response or error, this hardware IO will send that back to the multiplexer. And this point, event demultiplexer will forward and enqueue an event here in event queue. And after some point, when event loop will check the queue and we'll see the item inside, it will execute. It will be executed. So our callback will be called with error or with data. In our case, it says I have this data. So it's the basic concept of event loop, how the reactor pattern works. We have event demultiplexer there, we have event queue, and we have some hardware IO here. But today I want to dive deeper, especially on this part, on the event queue part, because everyone says like we have one queue, but actually we have 4 of them, and that's no all the queues, because there are also 2 more queues in JavaScript level about which we will talk. And right now, I want to talk about Libyobi, because all that magic is done by Libyobi, inside Libyobi. It's a library. At the beginning, it's developed only for Node.js. But during the time it's developed, and right now Libyobi provides some APIs, and you can see some other runtimes which use Libyobi inside. So let's take a quick look at architecture of Node.js and understand how our JavaScript code works with our operation system. Because basically JavaScript is a high-level programming language, and high-level programming language cannot work with operation system, right? But we have low-level programming languages, for example C, C++, and they can work with operation system. Basically, if we create a bridge between our high-level programming language JavaScript and C++ or C, then we can call a function from JavaScript and run some other function in C level and work with operation system. So we will talk about this middle part. This is Node.js, and let's understand the architecture. So we have V8 engine, Google's V8 engine. Node.js use this engine to execute the JavaScript code. And then we have the Libyobi, the most important library here. And after then, we have C++ bindings and core modules. So let's talk about them. Basically, you can create C++ script, and you can build it by Node.js builder, and it will generate .node file, which can be required by the JavaScript. So using this .node files, you can call C++ function from JavaScript. I guess many of you thought like you can require only .js and .json files, but no, there is a third type of file called .node, which is binding and which can talk with low-level language. So that's the main thing here. And after then, we have some other small libraries, CRS, Zli, and etc. So these are represent for a special thing. Like this zlib helps us to work with data compressions. This first one helps us to work with DNS stuff, and we have a few other small libraries there. But this is the main concept of main architecture of Node.js. So let's go ahead and talk about macro tasks. We have here event loop. We have here our index.js. It's running at this point, and it works. And after some point, the process exits. Also, event loop called semi-infinite loop. As you can see, this is our infinite loop. And event loop has some phases, and during that phases, event loop checks queue to execute some event. As I've said, we have multiple queues. So let's talk about the queues and understand what's the sequence of execution that queues, and how we can understand our asynchronous code. First of all, if you use set timeout or set interval, if you call them, then when this will be finished, your event will be registered at this first queue. So here, this is the first phase of event loop. After that, if you call any other IO thing, let's say file system or something else, at the end it will be registered here in this queue. Then we have separate queue for set immediate and separate queue for close events. Basically, whenever you create a connection with your database, and at some point when the connection will be closed, you will receive your event from this queue. And as you can see, we have 4 different queues inside event loop. So it's not a single. And that's the reason why sometimes we escape something, but the actual result is different. So let's understand how the process starts, how the event loop tries to check phases, and when the process exits. When the node, let's imagine we have set timeout with 5 seconds. In 5 seconds, your callback will be executed. When we run the index.js file, there is a refs reference variable inside Libyobi, which is by default 0. When we call set timeout, the refs counter will be increased by 1. And at that time, event loop will start the checking. So it always checks each phase, each queue to get the event until the refs count is not 0. Because when the refs count is equal to 0, then our process will exit because there is nothing else to wait for. And imagine our set timeout finished and our callback executed. Then the refs decreased by 1. So our refs count becomes 0. So if there is nothing else inside our callback, like set timeout or any other IO request, any other asynchronous stuff, then refs will become 0 and event loop will pass all these 4 phases. And at the end, as this is 0, then process will exit. So I guess now you can understand how the single set timeout will start to work and when your node process will exit. But I want to show you a quick demo. So with code. So we have this diagram here and we have this code here. I've set timeout which should be executed in 1 second, and I have single simple file system read. So let's understand how this whole concept works. Whenever I run this index.js, V8 engine will execute the JavaScript code. We have asynchronous calls here. So some controller in C level will start work and our refs count will be increased by 1. So it will become 1. Then when this function will be called, another C controller will start work, and again our reference counter will be increased by 1. So it will become 2. Then event loop starts checking the queues. It starts check each phase for a registered event, but as there are no any registered event yet, it will continue go through the loop until there is something registered, because refs count is equal to 2, so the process cannot be exit. At some point when something is finished here, let's say set timeout or file system, in our case, in my example, it's the timeout. When timeout finished, the multiplexer registers this event for execution inside this queue, and reference count decreased by 1. So it will become 1. And JavaScript will execute that callback. So in console log, we will have this log because we are executing this function. Then when file system work finished, again, we are registering another event here in this queue, and we are decreasing the refs counter. It will become 0. And again, the same thing. Create engine will execute this callback and will return this log read file. And as long as as our refs count is 0, then process will be exit. But as long as the refs count is not 0, then the process will continue work, and the event loop will go through all these phases and will check to execute some event. Let's look another example. Example 1. We have set timeout and set immediate. So looking at this diagram, you can understand how this will work, and you can say what's the result of this code. I guess probably you will say we will have set timeout, then set immediate, because the set timeout queue is before the set immediate queue. Let's just run and see the example. So we have set timeout at first and then set immediate. But let's try to run this more times. As you can see, in this case, the set immediate works faster than set timeout. So why? Because this example is a little tricky. So whenever we run our file, let me zoom. Okay, whenever we run our file, Libyobi will do some stuff internally to register this set timeout 0. So probably Libyobi needs some time to work on this. But for set immediate, we don't need to spend much time because the immediate is registered immediately. So if this process here takes, or this here has some delays, then event loop starts working and it checks this queue. As it's empty, it goes through other queues. And as this is already registered immediately, our set immediate callback will be executed. But when the process does not have any delays at this point, at the starting point, it registers the set timeout immediately again. And when our event loop starts to work, it already sees something registered in the timeout queue. This is the tricky case here. But if we take a look at the second example, so here I have file system read file function called, and inside I have set timeout and set immediate. At this time, I can be sure that my output is this. Set immediate and set timeout. Why? Because when we run read file, it will be executed at some point because it will be registered here in this queue. And when we execute this callback, JavaScript will try run 2 more asynchronous functions, set immediate and set timeout. Set immediate will be registered immediately and set timeout will be registered at some point. But as our next queue is the set immediate, as our next phase is this, then we are sure that set immediate log will be at top, not the set timeout. So if you run this multiple times, then as you can see, the output is always the same. Okay, we can continue. We talked about macro tasks, and let's talk about micro tasks. at each phase here, after the each phase, we have another phases with this JavaScript logo. You can think about this like it's the JavaScript execution. Yeah, that's right. But we have two more queues inside JavaScript, not Libyobi, because these queues were in Libyobi. So we have Process.Next and we have Promise, right? But these are handled in JavaScript level. These are also asynchronous functions, but they, they have a higher priority than, for example, something else. That's why it's handled in JavaScript level. So, okay. JavaScript has two more queues inside, and the first one was the next tick, and second one was the promise. And the priority of next tick is higher than the promise. And whenever JavaScript tries to execute something, after the execution, it checks next tick queues. If there's something registered, then JavaScript tries to run them. After then, when the next tick queue finished, JavaScript tries to check promise queue. If there's something registered, then JavaScript runs and executes them. And when the next tick queue is empty and the promise queue is empty, then Libyobi can continue to check the next phases. Let's say after timers, JavaScript does some execution, but if we have Process.Next or promise inside timeout, then JavaScript will try to run them. After then, Libyobi can continue and do other things. So we can have other examples here. Sorry. So example 1. We have Process.Next and we have promise resolve, then and console log. As you can see, the next tick's queue has a higher priority. Then I think the result is clear for you that the next tick should be executed before the promise. So I tried multiple times and the result is the same. But let's take a look at other examples. Let's say this example 2. We have Process.Next tick, promise resolve, set timeout, and set immediate. But let me change the diagram. So here is our full diagram. So you can try to understand this code with this. So as I have said, this JavaScript phase tries to check the next tick and promise queues, right? So if you run this script, then we can see like one item will be registered in the next tick queue, another item in the promise queue, and after then we have asynchronous functions, right? But JavaScript should finish this two functions and then can continue to work on these ones. So they will be run inside Libyobi because they are I/O operations, but they will be executed in JavaScript later when the promise and next tick will be executed. So let's try run example 2.js. So we have next tick, promise, set timeout, and set immediate. So how many times we try, we will have basically the same result. And at this time, as you can see, JavaScript spent some time here to execute the next tick callback and promise callback. And I guess that's the reason why the set timeout always becomes first than the set immediate, because we are saving some time here and the Libyobi registers this set timeout event here before the event loop starts to try check queues and execute them. So
5 minutes left.
Okay. Let's see the third example. We have process next ticks, nested process next ticks, right? Let's understand how this will work. So whenever process next tick calls, this will be registered. Then our callback will be executed, and we will have 2 more next ticks registered, right? Let's run this. Next tick 1, next tick 2, next tick 5. Why? Because we are registering this, then we are executing this callback, then we are calling this 2 next ticks, and we are registering this next ticks in sequence. So this will work. Then we will start 2 more next ticks, but they will be in queue. So, but before them, we have another item already registered, which is this one. So that's why we have next tick 5 here. And then we will again register 2 more next ticks. And if you look, the last look should be like this: 3, 4, 6, 7. Let's look the last example, 4. You already, I guess, hear that the set timeout 0 can be run even 5 seconds later, right? Because the event loop can be blocked. So how we can block the event loop? If you run process next tick recursively, like let's say, I guess we have 20 million, right? 20 million recursive next ticks, then the event loop will be blocked, and until all the next ticks will not be finished, our set timeout callback will not be called. So let's try that. As you can see, it takes some time, but actually we wrote here 0. If I increase this value by 10 times, you will see huge delay here running. So why? Because at this phase, this starting phase, we are trying to run 200 million, billion recursive next ticks, and that's why our event loop blocked.
2 minutes left.
Yeah, it can't start to work. So Libyobi works with non-blocking I/O and blocking I/O. To be short here, this is asynchronous part, and there are some operation system stuff that work that they are blocking. For example, the file system. If you run any file system process in your thread, then your thread will be blocked. So for that reasons, Node.js use thread pool, and in case if you have lots of file system calls, then some of them will be in waiting mode, because by default Libyobi creates 4 threads in thread pool, and but you can increase that by this environment variable. But nowadays, after the Libyobi.130, you can create up to 1024 threads. Previously, it was 128. So if I try this, no, actually, okay, you can try this, and you can run some Node.js process, and you can open the monitor here, and inside this, under
1
the
minute left.
threads, you can under the threads, you can see how many threads actually Node.js creates, because the simple Node.js instance creates 7-8 threads, because V8 engine uses threads for V8 execution, use different thread for garbage collection and for other stuff as well. So that's why not just called single thread, but it's actually not single threaded. So I guess that's all. Uh, I thought I will have some more time. I just keep some uh, stuff, but I guess it was interesting for you. So that's all.
Thank you, Nari. How do you feel now after this, after passing this, actually, the conference? What was your experience?
Oh, pretty great, actually. I thought it will be difficult, but not so. It wasn't so.
Yeah, that's brilliant. You are very good. And now I would like to ask all the audience to thank Nari for all the experience shared here. Guys, we are starting the Q&A session in 10 minutes. So Nari, thank you so much. Now you can take you can get some drinks and so on and get prepared for the Q&A session that starts in 10 minutes. Thank you so much. Don't go away. Just keep connected, and we'll connect you back in 10 minutes. Thank you. So now you are free as well to get and do your own stuff. Just get prepared for the Q&A session. Keep in mind that our speakers will be here to talk to you. And we also would like to thank the Salesforce, Heroku, our sponsors who have invested into these platforms and so on. And also to all our partners who have dedicated their speakers and their time. And to all the committee managers that actually assisted us in getting this conference live. This is the first global online conference, and we hope that all the small glitches and so on just don't bother you that much. Thank you, and see you soon.